Hello everyone, welcome back to the series of Pandas. As we know, Python Pandas is a widely used data science library and it also offers many useful functions. Among many other functions, the functions offered by Pandas also include many useful statistical functions. In this video, we will discuss on descriptive statistics with Pandas. We will be discussing on the following functions: mean and max, mode, mean and median, count and sum, and finally quantile and var. So let's get started with mean and max. Let's try to understand what the mean function is and what is the basic syntax of the mean function. The mean function is used to calculate the minimum value from a data frame. Either it be in the format of axes or in the format of rows or columns. As you can see, this is the basic syntax of the mean function. We need to pass the data frame along with the mean function, and the mean function accepts three parameters. The three parameters are axis, the skip NA, and numeric only. So these are the three parameters that are accepted by mean function. Now let's try to understand the max function. In order to understand the max function, before we need to get started with the syntax. This is the basic syntax of the max function. It is similar to what we have learned on mean function. We need to have the data frame and we need to use the dot notation along with the max function. It also accepts three parameters: axis, skip NA, and numeric only. Now let's try to understand these parameters. The mean and max functions find out the minimum or maximum value respectively from a given set of data. This is the basic syntax of mean and max function. Let's try to understand the parameters. Now axis means axis 0 or axis 1. In case you don't know what an axis is, let me show you the axis of a data frame. As you can see, the horizontal rows are the part of axis 1 and the vertical columns are the part of axis 0. If we don't pass any parameter on mean or max, then by default the calculation is done along the axis 0. That is index 0 column 1. Now let us move ahead to the next parameter, that is skip NA. The skip NA accepts boolean values, either true or false. The skip NA parameter when passed skips the null value when computing the results. So whenever we have a null value, the skip NA will basically skip that null value. Now let us move ahead to the third parameter, that is numeric only. The numeric only accepts boolean value, that is either true or false. The numeric only is used whenever we want to display only the numeric values from a data frame. Now let us try to understand this better with an example. In this example, as you can see, we have once again the COVID-19 data, the updated one, and here we are using the df object in order to store the data frame, and we are printing this data frame. So let's try to find the minimum using the mean function. Here as you can see, I have not passed any parameters, so by default this will calculate the mean along the axis 0. So let's try to execute this code. As you can see, this is our original data frame, and mean function, what it does, it has calculated the mean value from the axis 0. As you can see, as per as the axis 0, what it will do, it will calculate the minimum of each and every column. So from the first column, as you can see, China gets printed because C is the first letter which comes before I and U. So from the second column, you can see 1590 gets printed because 1590 is the minimum value in total cases, and 45 gets printed from the column death because 45 is the minimum value from the death column, and 148 gets printed from the recovered column because 148 is the minimum value from the recovered column. Let's say if we need to perform the calculation along the axis 1, what we need to do is we need to pass the parameter as axis 1. So this way it will calculate the minimum value along the axis 1. Let's try to execute this code. As you can see, from this entire data frame, the minimum value along the axis 1 has been calculated. So from the row 1, the minimum value is 45. It is to be noted, all the numeric values are given as higher priority when compared with letters. So 45 gets printed from the first row. From the second row, the minimum value, that is 3312, gets printed, that is from the index 1, and from the index 2 the 4055 gets printed, and from index 3 12428 gets printed because it is a minimum value among all. In the same way, we can also calculate the maximum among all in this data frame. So in order to calculate the maximum, we have to use the max function along with the data frame object. So let's use the max function. So let's execute this code and get the output. As you can see, the maximum of all is being calculated for the axis 0. Since we have not passed any parameters, the default axis which it takes is the axis 0. Let's print this data frame in order to understand better. As you can see, the maximum value from the axis 0 is being calculated. Since we know the axis 0 is basically the columns that we have, so the maximum value from the column country is USA, and the maximum value from the total cases is 188592, and the maximum value from the death is 12428, and the maximum value from the recovered is 76238. So this way we can calculate the maximum. So in order to calculate the maximum along the axis 1, we have to pass the parameter axis as 1. Let's execute this code. So in this case, the maximum has been calculated along the axis 1, that is row wise. So for each and every row, the maximum value has been calculated. This is the first row and this is its maximum value. This is the second row and this is its maximum value. Third, and this is its maximum value, and this is the fourth row and this is the maximum value. Since we have passed the parameter as 1, therefore the maximum value for each and every row has been calculated. Now let us try to understand the second parameter. The second parameter is key panic. In this COVID-19 data, as we can see that the second element of the country column contains no value. So while computing the minimum and maximum with the skip and parameter, this element will be skipped. By default, the skip and is always set to true. Now let us move ahead to the next parameter, that is numeric only. Before understanding what is numeric only, let us print this data frame. As you can see, I have used the min function. The min function, what it does, it calculates the minimum along the axis 0 by default. Since I have not passed any parameter, it will calculate the minimum value against the axis 0. As you can see, the first column which contains China gets also printed. So if I need to calculate the minimum of only the numeric values, what I will do is I will use the numeric only parameter. And I will set the value of numeric only parameter as true. Let's execute this code and understand it. As you can see, the minimum of all the values of axis 0 has been calculated for only numerical values. I hope the concepts of function minimum and maximum is clear. Now let us move ahead to the next module. Central tendency is a descriptive summary of a dataset through a single value that reflects the center of data distribution. So central tendency of a dataset can be calculated using mean, median and mode. In this section, we will learn how to calculate the central tendency in Pandas. Let us get started with mode. Function mode returns the mode value, that is the value that appears the most for a set of values. So this is the basic syntax of mode, or rather we can say how to calculate mode of a data frame. First, we need to use the data frame object along with the dot notation, then the mode function. Let us go through an example. This is the dataset that we have. This dataset contains two columns, name and marks. These are the name of the students and these are the marks of the students. This dataset is being passed to a data frame and the data frame is being printed. This is used to beautify in order to separate the mode calculation from the dataset that gets printed. So in order to calculate the mode, what we need to do is we need to use this data frame along with the mode function. As we use the data frame along with the mode function, what it does, it calculates the mode and displays the mode. So let's execute the code. As you can see, the mode of this data frame is 10 You can see that Bob, Rex, Rob and Sam gets NaN. The reason why they get NaN is because they are string data, so we can't calculate mode of a string data. Now let us try to understand the working mechanism of this mode function. Since we have not passed any kind of parameter, what it does, it takes the access value to be as 0. We all know that whenever we set the access value to be as 0, it calculates column wise. So it has calculated the mode column wise. I hope this is clear. So let us move ahead to the next module. Next we will try to calculate mean of a data frame. So in order to calculate the mean of a data frame, we will use the mean function. Mean basically stands for average. So if we need to calculate the average of a data frame, we will use the mean function. This is the basic syntax of the mean function. That is, we have to use the data frame object with the dot notation along with the mean function. So in order to use the mean function, we have to use the dot notation, and it accepts the following parameters, that is access, skip NA and numeric only. Now let us try to understand this better with an example. In order to calculate mean, what we'll do is we will simply use mean instead of mode. And we will execute this code and we will check out what is the mean of this program. As you can see, the mean of this program is 16. This means that average marks of the following student is 16. So this way we can calculate the mean of a dataset. If we need to pass the following parameters, we have to pass these following parameters here. As of now, we will not pass the parameters since we have already learned how to pass the parameters in minimum and maximum function. Now let us try to understand the median function. Let's get started with the median function syntax. The function median returns the middle number from a set of number. This is the basic syntax of median function. So in order to calculate the median, once again we have to use the data frame, the dot notation and the median function. It also accepts 3 parameters, that is access, skip NA and numeric only. Let us understand this better with an example. In order to calculate the median, we will use the median along with the dot notation. So this way we can calculate the median of a data frame. Let's execute this code and understand it better. As you can see, the median of the data frame gets printed. So the marks to be a stan is the median of the code. So this is the median. I hope this is clear. So let's move ahead to the next section. Now let us try to understand the function count and sum. Let us start with count function. As you can see, this is the basic syntax of count function. The count function needs the data frame object followed by the dot notation and the count function. These are the following parameters which are accepted by the count function, the access and the numeric only. So 2 parameters are accepted by count function. In order to understand count function in a better way, let's go through an example. As you can see, this is the data frame that we have. In this data, we have the marks and the name of the following students. So if I need to use the count function, what I need to do is I need to use the data frame, the dot notation and the count. So count, what it does, it calculates the number of elements present in a particular row or particular column. By default, it will use the access 0. So as soon as I execute the code, you can see the output here. It signifies that the name column have 4 elements and the marks column have 4 elements. By default, the access 0 is being used. If I need to use the access 1, I need to pass the parameter as access 1. Let's execute the code. As you can see the output, the number of elements in each row has been calculated. In the first row, as you can see, there are 2 elements. In the second row, also 2. Third row, 2. In the fourth row, also 2. So this was all about count. Let us move ahead to the next function. The next function that we have is sum. Sum, as the name signifies, is used to calculate the sum of a particular column or of a particular data frame. So this is the basic syntax of the sum function. The data frame along with the dot notation followed by the sum method or the sum function. These are the following parameters that are accepted by the sum function. The first parameter which it accepts is access, followed by skip NA, numeric only and minimum count. As of now, we already know about access, skip NA, numeric only. In this section, we will discuss about mean count. So let us try to calculate the sum of a data frame. In order to calculate the sum of a data frame, I will use the data frame object along with the sum method or the sum function. So let us try to execute the code and see the output. As you can see, what it does, it gives the sum of all the strings that are available in column name, and it gives the sum of the marks of the students in the column marks. So this way we can calculate the sum using the sum method or the sum function. Let's say if I need to calculate the sum of only the marks column, then I have to specify the column name. Let's say if I need to calculate the sum of the marks column, then I need to specify the column name along with the data frame object. So let us specify the marks column. This way it will calculate the total marks of the marks column. Let us execute the code. As you can see, this is the total marks of the marks column. So this was all about sum. It also accepts parameter like access. So if I need to pass the parameter access, then I have to use the access keyword and set the value as 1. By default it uses the access 0. So if I specify it as access 1, it will calculate the value row wise. So this is the output after the access 1 is being passed. Now let us try to understand the parameter min count. The min count, what it does, it calculates the sum on the basis of the minimum count of data. Let's say if we set the minimum count to be as 2, minimum the data frame should have at least 2 elements in order to calculate the sum. If the data frame doesn't have 2 elements, it won't calculate the sum. So let us try to understand it in a much better way. Supposingly this is the data frame that we have, or the data set that we have. It contains 4 values. Let's say if I remove 2 values from here, so this data set now contains 2 values. Now if I pass min count to be as 3, so what it will do is it will look after 3 elements. So if the condition satisfies, that means if this data frame or this data set has 3 elements, then only it will calculate the sum, else it won't calculate the sum. Let us try to execute this code and understand it better. As you can see, the sum is not being calculated. It says NaN. Since it doesn't have 3 values or 3 elements, it won't calculate the sum. Now let us try to change this value and understand it. As soon as I pass the value to be as 2 and execute the code, the sum gets calculated. I hope this is clear. So this was all about count and sum function. Now let us proceed to quantile and var function. Now let us try to understand quantile and var function. But before getting started with quantile and var function, let us understand what quantile and var means. As you can see, I have a data set of salary of 10 people which contains 1700, 2000, 1500, 3000, 4000, 5000, 3500, 6500, 4500 and 3600. So before understanding what a quantile is, let us understand what do you mean by percentile. So before getting started with quantile, we have to understand what percentile means. Before calculating percentile, we have to sort this data. So this is the sorted data. As you can see here, the first element is 1500 and the second is 1700 and the third element is 2000, the fourth element is 3000, the fifth element is 3500 and the sixth element is 3600, 7 as the 4000, 8 as 4500, 9th as 5000 and 10 as 6500. So let's see if I need to find the fifth element. So this is the fifth element, which is 3000. Now let's see if I need to know what is the 50 percentile of this data set. So 3500 is the 50 percentile of this data. What it actually means, it means that 50% of the values are less than 3500, or we can also say that 50% of the values or the 50% of people's salary is more than 3500. So this is what percentile is. Let's see if I need to know what is the 90 percentile. Here by looking at the data, we can see that the 90 percentile of this data set is 5000. This is what actually percentile is. So percentile says that what is the amount of, or what is the majority of data, what is the percentile of data which contains a particular value. During this data set, you can see 90% of the data is less than 5000 and 10% of the data is more than 5000. Now let's say if I need to understand what quantile is. Quantile is basically the percentage amount of a particular data set. In this case, the 25% of this data set can be a value. The 50% of this data set can be a value. Let's say the 50% in this data set is 3500. 75% can be a value and 100% of this data set can be a value. So we can say quantiles are points in a distribution that relate to the rank order of values in that particular distribution. Now let us try to understand one more term in Pandas. that you might come across, that is quartiles. Let us assume this is a dataset and let us divide this dataset into 3 points. As you can see, this is the first point, this is the second point, and this is the third point. We can name this point as Q1, Q2, Q3. Let's name this point as Q1. Let's name this point as Q2. And let's name this point as Q3. As you can see. So we have divided this entire data set into 4 chunks. This is the first chunk, this is the second chunk, this is the third chunk, and this is the fourth chunk. Here Q1, Q2, Q3 are 3 points that divide a distribution into 4 parts. The 4 quantiles are called the quartiles. So these 4 quantiles are basically the quartiles. Now let us try to understand the quantile and var function. Let's get started with quantile function. So this is the basic syntax of quantile function, that is df, the data frame object, followed by the dot notation along with the quantile function. So these are the parameters which are accepted by the quantile function, that is a quantile value, access, and the numeric only value. This is the important point that is to be noted. The value of q should be greater or equal to 0 and should be less than equal to 1. Now let us try to understand this with an example. Let's say if I need to calculate the quantile of this data set. So what I need to do is I need to use the data frame object and I need to call the quantile function and I need to pass the quantile value. Let's say the quantile value is 0.25. As we know, the quantile value should be greater or equal to 0 and should be less than equal to 1. Let's execute the code. As you can see, the quantile amount is, or the quantile marks is 43875. That means 0.25 people are less than 43875. So this was all about quantile. Now let's try to understand var. The var function computes variance and returns unbiased variance over a requested access. Let's try to understand this with an example. So in order to calculate the variance, what I need to do is I need to call the variance method. By default, it uses the axis 0. So on the axis 0, it will calculate the variance. So this is the variance that is being calculated. So this is the basic syntax of variance function or the var function. It accepts 3 parameters: access, skip NA, and numeric only. So this was all about descriptive statistics with pandas. I will discuss about the other models of pandas in my next video.